Welcome to today's video on tree diagrams. So this is using tree diagrams to create probability. So today's example, we have some boxes. So our boxes are A and B. They contain 4 counters each. So box A contains 2 red counters. So there's 2 red counters in box A, and box B only has 1 red counter. So then we also have some green counters in there. Box A has 2 green counters, and box B has 3 green counters. So the first question is, what is the probability of selecting a red counter from box A? So we can see that there should be a different probability for selecting counters from box A and box B because they have different amounts of counters in each box. So for box A, so the probability of a red counter is going to equal, so we've got 2 reds over a total of 4. So if we simplify that fraction, so I'm going to divide by 2 on top and bottom, I have a half. So for box B, we want to know the probability of red. So this will be 1 over 4. And we can't simplify that any further. So I don't know why I started to draw like I was going to. Okay, so, and that is part A and B done for this question. Okay, so the next part is that we are told that you're going to choose a box at random and then a single counter is selected. So this is a multi-stage experiment and we can use our tree diagram to represent all the options that are available to us. So I'm going to start my tree diagram and I'll do this for my box A and my box B. So when I'm making my first random choice, there is a half chance, because there's only 2 options. So there's a half chance I'll choose box A, and there's a half chance I'll choose box B. So then from box A and from box B, you have your different red or green markers. So you can only get a red or a green. And then we have red and green again down here. But the probability of choosing a red or a green is going to be different. So for box A, my probability of choosing a red is going to be a half, and choosing a green is going to be half as well. For box B, my chance of getting a red is going to be a quarter, which means that my chance of getting a green is going to be 3/4. So from this step, so I've done part C now, so represent the options available as a tree diagram that shows all possible outcomes and related probabilities. So what I'm going to do now is I'm going to write out my outcomes. And for each outcome, I'll write something like this. I'll put it in brackets and I'll say, I got A and then red. Or I got A and then green. So there was 4 total outcomes that I could have had. B red, B green. Okay, so now I have all my outcomes. So I want to know the probability of each outcome. So the probability of my outcome is I'm going to times together each probability from my stems. So I might draw this in a different color to try and make it a bit easier for us to follow. So my first part comes from here. So that is my half. And then my second part comes from here. So that is times my second half. And a half times a half is equal to a quarter. Okay, so I'm going to do the same thing for my next one. So I've got a half times a half. So maybe I should do this in green. So when it comes to box A, it doesn't make a difference. So the probability of picking a red or a green is going to be exactly the same. They're both going to be a quarter chance. Okay, this is going to change up a little bit when I get to box B. So box B, the probability of getting the B box is half. Oopsie daisies, that was supposed to be in red. So the probability of getting the B box is half, and then the probability of choosing red is only a quarter. So if I do half times a quarter, then I have 1/8. And remember, when you're timesing your fractions, you're timesing the tops, so 1 and 1 times the bottoms, so 2 and 2. 2 and 4. So 2 times 4 equals 8. And then I've got my last one. So the probability of getting green, and I know because there's more greens in box B, this should be higher. So the probability of getting box B is half still. And then the probability of getting green from box B is going to be 3/4. So if I times my 1 times 3, I get 3. And then 2 times 4, I get 8. So these are all of my possible probabilities. So you've got the biggest chance of picking a green counter from box B out of all of your choices. Okay, so now we're going to move on to our next part of the question. So what is the probability of selecting box B and a red counter? So the probability of selecting box B and a red counter is 1/8, and I know this because I've already worked out my probability up here before. So the last part is we want to know the probability of selecting at least a red counter. So there's two outcomes where I've selected a red counter, and this is from box A or box B. So what I'm going to do is I'm going to add together my two different outcomes. So the first one was a quarter for box A, and then in box B, you have an 1/8 of a chance of selecting a red counter. So to add these together, I can't do this when I've got two different denominators, can I? So what I'm going to do is I'm going to change a quarter to be over 8. So if I'm going to change my 4 to an 8, I'm going to times it by 2. Whatever I do to the bottom, I'm going to do to the top. So this will give me 2/8 plus 1/8. And my total is going to be 3/8. So my probability of selecting any red counter from any box is going to be 3/8, which is the same amount of just selecting a green counter from box B, which isn't really that high. Okay, so I hope you understood how we work out our probabilities from a TU diagram when we have multiple stages in our experiment.